Okay, so today my topic is how to build real-time image classifiers using Azure Custom Vision Service. First, I thought I'll cover this one, but then when I was working through it, I thought that the learners who are using computer vision and custom vision might get some questions as to what is computer vision and what is custom vision and what are the differences. So I'm going to cover both computer vision and custom vision. So before going to that, I think because only 4 of you were there in Wagner's session, I'll just show you a little bit of Azure Cognitive Services. So to get to Azure Cognitive Services, you just need to type microsoft.com and /cognitive. And this is the cognitive services. And if we go through, so these are the cognitive services that Microsoft offers: decision, language, speech, vision, and web search. I will be covering the vision part of it, the vision, and under vision, under vision I'll be covering the computer vision and custom vision part of it. So this is the basic intro of Azure Cognitive Services. For those of you who were not part of Wagner session, I just wanted to show you where to go to. So before I start off, a little bit about myself. My name is Indira and I'm the Microsoft Data Platform MVP. I have over 15 years of experience and in dealing with databases, mainly SQL Server, mainly Microsoft Stack. I'm mainly into BI and slowly getting into AI as well. I'm a speaker and a co-organizer, as some of you might know, for 2 meetup groups. One is the Data Insights and Power BI meetup group, and this meetup group, Auckland Artificial Intelligence meetup. And also we organize once a year SQL Saturday, which is mainly on SQL, and that is also organized all over the world. They pick one Saturday, so we usually organize in August. And apart from these, I like volunteering and sharing my knowledge. And as part of this, from 2016, every year I run some courses for kids. I started off with primary kids. Now for the last 2 years, I started teaching 10 to 16-year-old kids about databases and Power BI. And I think for the last 2 years, 22 kids know Power BI, so which is a good achievement. And now I think because every year I conduct competitions between the kids, and Reza and Laila were the judges for the last two competitions, and they said that they are really good, so they can come and present in our meetups. So last meetup, Medha presented on past. What was your title? Past historical event for 10 minutes. So every month, one kid will come and present. That will cover 14 kids so for the year. So that's a little bit about me. And so today's agenda, as I mentioned, it will be computer vision, followed by a small demo, and custom vision and a demo. And also at the end, I'll maybe listen carefully so that I'll ask you questions between. I'm telling you the question, so you can answer the question at the end of the session. What is the difference between computer vision and custom vision? That will be your question. So let's proceed. What's Azure Computer Vision? So what is computer vision? Computer vision is an API that is provided by Microsoft. And what does it do? It does image classification, content moderation, OCR. Any idea what OCR is? What is OCR? Optical character reader. I also thought recognition, but I searched online, so it is OCR is optical character reader. So what does it mean? Yes, yeah. Okay, facial recognition, what does it mean? Any examples? No size. Yeah. Yeah. Oh, yeah. Airports use them, and also when you sometimes want to log in into your laptops, you use facial recognition. And what do you mean by image classification? Any ideas? Any answers?
Categorization of images.
Yes. Okay, so if you have a bunch of photographs of, let's say, bananas, and if you have a bunch of photographs of apples, so you can classify them as apples and bananas. So that's the image classification. What is content moderation? Yeah, or yeah, inappropriate content. Yeah, that is sometimes you see the what do you call adult only content. So which is should be restricted for kids. That kind of stuff is called content moderation. So all these kind of stuff is provided by computer vision API. Okay, let's move on to next one. So face recognition. What does face recognition API do? That is offered by Microsoft. Face detection detects faces and their attributes in an image. Attributes can be gender, maybe what color of hair, what color of eyes, those kind of stuff, and whether, yeah, okay. So face verification, if there are two similar faces, it verifies and says that it's two similar faces, and also grouping and face identification. Sometimes on Facebook you see, shall I tag this with, and then it suggests the name. So that's the face identification part of the API. Next one, this. So here this is face API. So it predicts the gender, age, whether the person is wearing glasses or not, and what the emotion is. Yeah, I think if the teeth are shown, then it shows happy, and if they are not shown, neutral, that kind of stuff, sad. And along with what Face API does is it gives you a JSON format, the face ID that it has given, and also the rectangle. So what are the coordinates? What is the top, left, width, and height? And also the face attributes, like how I mentioned, whether how much baldness, 18% here, because I think the forehead is high, and is it invisible? Not invisible, so false. Hair color says black, and the confidence level is 99%. So the API is 99% confident that the hair color is black. And brown it's sometimes predicting maybe there is a little bit of color which we are not able to see in this photograph. Maybe that is 0.7. That is 0.7 means 99%, 0.7, brown color. So those kind of attributes are given. And what do you feel about this? Angry, right? And it has detected one face. See detection result, one face, and the JSON says that anger is 96%, 96.8%, and with contempt is 4, and disgust. So it gives the scores against those attributes: anger, contempt, disgust, fear, happiness, neutral. Neutral is not there. Sadness is also not much. Surprise is not much, but anger is, and we can see that it is visibly. So the computer vision API, it helps you to analyze an image, and also if you upload any document that is having a text, it converts the text into a set of words, which you have seen in Wagner's session. And also it generates a thumbnail, and also it recognizes celebrities. I'll show you a website shortly on that. And it also if you upload a photo like this, it categorizes with the confidence levels, it categorizes, see if you see, you can see a lot of grass, right? So 99% it is grass, and it's outdoor, so that is also 99%. And there is a cow there, which is 99%, and it is categorizing it as a field. And the brown color, animal, obviously it's an animal. So there are lots of categorizations with the words, which has been trained by Microsoft. We can't train, if we want to train by uploading some images, we can't train in computer vision API. So, and then you get a caption here, describe. So 97.5%, a brown cow standing on top of a lush green field, which is what we are seeing. And another caption is a cow standing on top of a lush green field, which is another way of saying it. And a large brown cow standing on top of a lush green field. Okay, so OCR is like you can see closed, so you can see closed window. So you can, when you upload this photo, you get the conversion as you get the words in as closed and when one door. And this is because it is typed, it's really straightforward, it's not handwriting, so it's easy to convert the convert to words. Okay, so there are some websites which are powered by this computer vision. We can have a look at it, captionbot.ai and Celebs Like Me and like.me and Project Murphy. And this is what Uber is using Face API. Have you, I think you all must have taken Uber, have you? And do you know that they are using the Face API to recognize the drivers? So yes, yeah, they use the Face API to recognize the drivers, to verify the drivers without slowing them down. So this is what the product manager of Uber, Dima, said when they did the case study, when Microsoft did the case study. And let's have a look at the demo. So let's go to computer vision. Okay, so look, if you have a look here, see it is marking the rectangles which we have seen. So rectangle is x, y coordinates and width and height, and also it is doing object detection. So it is recognizing that, detecting that there is a person with a confidence level of 76.4%, and also there another rectangle with another person, detecting another person with a confidence of 62.4, and there is also a subway train. It is detecting the object as a train, and also with lesser confidence it is detecting as a land vehicle. So these are the attributes, and it is tagging names are train with a confidence of 99%, and the platform, station, which is all true, right? So station, subway, clothing, because it's looking at clothes as well. So these are the descriptions: train, platform, station, building, indoor, subway, track, walking, waiting, pulling. All these words are making some sense, right? So these are the, and here, if you look closely at this, in these, whether it is black and white, it's not black and white, it's color, and also the content moderation. In terms of content moderation, it is showing adult content false, because this is not adult content. It is scoring, and adult score is less than, I think if the threshold is 50%. If it is 50, if it is more than 50%, maybe it scores as true probably. And another content moderation tag is racy. Is it racy or not? is it adult content or not. Those are the two attributes that it scores for content moderation, and RACI is false, and RACI score is 0.014, and it is categorizing categories names at the score is 98.8%, and it is not able to detect any faces. Dominant color background is black and it is fuzzy. So now let's upload one photo which it will detect. I'll use a photo that we have taken in Envision, and yeah, I forgot to tell you, three of the kids went to Envision forum. Have you heard of Envision forum? When Satya Nadella came, yeah, a couple of weeks ago, I think, yeah, last month sometime, can't remember the date now. Yeah, so three of the kids, see, these are the kids, 1, 2, and 3. That's myself, and this is Myra, and this is David, who is here, and I think I met Wagner as well there. So let's see what it scores. I haven't tried with this one. So it is actually, see the number of rectangles it has detected. So this is the face, 1 face, 2 face, small faces. This is for the face recognition, and it is recognizing the faces, the objects behind as well. And if we come here, it's tagging the person, smile, human face with all the confidence, and also gender, woman. And when we look at the descriptions, it is saying person, standing, group, people posing, photo. Yeah, we were posing for a photo. So the final this thing is, see, it's saying Annie, I don't know how to pronounce that. So standing in front of a crowd posing for the camera. And adult content false, and people, crowd, and faces. So it's recognizing and giving the gender and age. Age is 58 for somebody, gender male, and 29 as the age. So it is giving age for each of them. And I'll show you a little bit more in one of the websites as to what it gives for the age and gender.
How do you know which face is being described?
Which faces is being described. It depends on the, see, that's why it gives you the rectangle.
Gender male.
Yeah.
Well, there is one male there, okay. How do you attribute those parameters to a particular face? Where is the identifier?
There'll be IDs. So when you actually I'll show you in a minute.
Coordinates, I see.
Yeah, so they are coordinates. See here. Yeah, see here, each face rectangle. So based on that.
It's a face array, and on each one of them, you're going to have an object that says the information and the position of, and what is really bound that it recognizes that, right?
Yeah, I'll show you in a minute how we can use this information and display in a meaningful format. I'll just show you that. Okay, so that's computer vision. Yeah, that's the computer vision, and you have emotion APIs saying what kind, whether they are happy or not. Okay, so let's look at some of the websites that that have been built based on this API. See, let's look at, there is something called Celebs Like Me. So if you upload a photo, see, for example, this photo, this is uploaded, and then it matches with celebrities. 34% match with Alexandra Burke. Anybody knows who that is? Because I don't know. And Ruth. Anyone knows any of these? So these are all celebrities, and this is being matched with these 4 when you upload. So I don't know, so, but maybe let's try with Satya.
It says that it's like 34% only, right?
Yeah.
So, kind of, but not really.
Amanda Stenberg.
Yes.
Priyamani.
Like similarities on the
Yeah.
smile or stuff like that.
Yeah, smile, yes, yeah. And this one is I know that this is an actress in India, so Priyamani, I think actress, right? No, okay. Okay, so yeah, so this is one of the website that was created using this computer vision API, and I want to try this one. See, this is what the same photo that we have used. I have uploaded this one. Let's say I'll upload again. First, let's use this photo, and then see it is -3. Okay. See, this is recognizing this person as male and 31 years of age, and this one is female and 31 years of age. Yeah, and also if I upload the same photograph again, try another photo and use your own photo. So it went to the Face API, that's why it took a little bit of time. And David is 49 years. My daughter, she's not 31, but but see what it is tagging me as 11. So swapped. And this is his real age, 12. This is not his real age, 12. He is also 12. So all these three were 12. So this is 15. And it is recognizing behind face, and that is 31. And Myra says 24. So it's not that accurate, but it can be trained to become more accurate. So that's how old .NET. And I wanted to try caption as well. Let's see caption. Caption, what was that? Caption bot. Captionbot.ai. Okay. I haven't tried that. Let's try it. So let's upload a photograph. Same photograph. Let's see what it comes up with. Uploading image. Try again later. Okay. Okay, let's try what is there inside. Try another. Yeah, let's use this photo. Analyzing image, and then it is, I think it's a baseball player holding a bat on a field, which is what it is, right? Is it a baseball bat? Yes? Looks like it. Okay, so that's captionbot.ai. So you can use these APIs in your applications. So for example, if you want to have an unmanned reception for your office, you can put a camera, and then when it detects the motion, it can take a picture and then send an alert saying that if it is accurate, a 35-year-old male has entered your office, so that you can either make them enter, or maybe you do a face recognition. You have a database of photos and then match it with the person who is standing there, and then you can open the door or close the door. You can do all those kind of apps using these cognitive services, using the computer vision API. So that's the computer vision API. Let's see what is in my Okay, so how does the computer vision API you get used in C#? You can use this code, and when how to use this code is you create on the portal.azure.com, you create the computer vision API, and then you get some keys, and you can use those keys. See in the subscription key here, and there is an endpoint which is the URI. You have to have those two, and if you give those two, then you can use this particular code, and it's not a big code, so you can use that, and then create your application. And there is another code base in node.js. Anyone developers here? Yeah, what kind of, do you use Visual Studio or? So C# can be, yeah, can be useful for you. And there is a lot of documentation as to how to create that as a tutorial. I'll share with you those links so that you can just use them. And Node, if anyone is using node.js, you can actually use this as well. Any questions so far in computer vision? So all set for my question? Okay, so next let's...
Just one note on that one. That's like if you're doing configuration of a code, if you're using Power Automate or if you're using Logic Apps,
Yeah.
it's pretty much the same steps.
Yeah.
You install the cognitive steps, then you have the key and you arrive, and that's what they're going to provide to the connector.
Yeah, and
So behind the scenes, the connector is probably that code written somewhere.
Yeah.
That we're using the step.
So shall I show you how to create this thing, or I think I'll show you that. So what you do is you just go to portal.azure.com. Okay, so first thing is what you need to do is you need to create a resource. So create a resource, and here, what do you call? Computer vision. So if you search for computer vision, you can just hit create, and it will not take much time. Just give a name to that, AI Bootcamp Computer Viz. Oh, what happened? Okay. And subscription, you need to choose your subscription. I have a Visual Studio Enterprise subscription. And location, mostly close to us is Australia. So, or maybe Australia East, right? Start typing, yeah. Oh yeah, Asia Pacific, okay. And then pricing tier, usually you can use the F0, which is 20 calls per minute, which is a free tier. And then if you don't have a resource group, you can create new. I have an existing one, so I can just create that. And then once you create,
while we're waiting, how many people here are using Azure today?
1, 2, 3,
For you guys
4,
that are not using, do you know there is like a free offering on Azure that you can get? Because some of those services are free, and on Azure you can have like a
12 months free subscription, yeah.
a 12-month subscription.
You can
So if
trial,
go
yeah.
through Azure.com,
Only thing is it needs work account, not work or school account. You can't use your Yahoo account. I can use because I'm the MVP here.
so you should be able to take a look. Also, if you have a Visual Studio subscription, every Visual Studio subscription comes with for the A allowance. I think the Visual Studio Professional comes with $50. Visual Studio Enterprise comes with $250. Right? You can also use that.
Yeah. Initial credits are, I think, $250 you can use, yeah. Okay, so now it says your deployment is complete. So if you go to the resource, here it shows the keys. Okay, quick start itself will show the key and the endpoint. So these are the things that you use So this key can be used in here, and the URI, in the URI space, you can use the endpoint here. So you can try, all the developers who want to try, you can try, go home and try. So that's about computer vision.
Sorry,
So-
for non-developers, you can do it with Power Apps, I believe, these days?
Yes, Power Apps, yes. Power Apps is a good way.
Logic apps.
Yeah, Power Automate, and even Power Virtual Agents will be for Azure Search.
And, logic apps also. if you're on
Yes, yeah. Okay, any other questions? So are you a Power Apps user?
No, hopefully.
Yeah,
not
it's
yet.
very easy.
The right answer is not yet.
Not yet. Yeah. Maybe after this you can try. Yeah.
I've done Power Apps.
Okay, so yeah, you can use using Power Apps. You can use the Face API,
Yeah, it's very
Computer Vision API. Okay, let's move on. Azure Custom Vision. What does custom mean? No answers? Do your own one. Yes, that's a best answer. Okay, so what does custom mean? Custom vision, see, basically these are the simple steps that you need to follow. First thing is, you are uploading your own images and training the service to to label the images and identify the images. Once you upload, the steps you follow is, once you upload, you train with the labels. And then once you label the images and train, then you can evaluate using a REST API. And then that REST API, same, it creates the prediction URL with some keys and endpoints. So those two keys and endpoints, you can use it in your applications. So you can prepare your data. So for example, you have bunch of photographs, maybe a bunch for apples, bunch for bananas, bunch for oranges. You group them in 3 folders, and that comes under the preparation of your data. I'm just taking simple examples because bananas, apples, everyone will understand. Some of the use cases may be, if you have in healthcare, if you have some healthcare equipment, so you can group them by scissors, surgical equipment, and or even the body parts, hands, if you have some images of those sort, particularly when you are doing x-rays and stuff, this will be useful by classifying them. Then after you classify, after you prepare, then you build and train. So for building and training, you upload those images with different tags so that the machine learns. And then you train use the train. It's very simple. I'll show you how to do that. And then once it is trained, it gives you the score of the model. And if you are happy with the score, then you can deploy the model. If you're not happy with the score, what do? Train more. So upload more with different angles so that it recognizes. Okay. So custom vision, again, upload images, train, evaluate, and you can do this cycle. If you're not happy, then again go and upload more with different angles, and then make the application learn so that it helps you, it helps to improve the classifier.
Sorry, can I ask one question? What's the difference between the REST API and API?
REST API and API Wagner.
API is a generic name for an application
Programming interface. Yeah.
programming interface, right? A REST API is an API that is using a specific format, that is the REST format. And that REST format dictates to you how to construct the path, right? So that they help you to easily remember how to get to a certain operation by defining path to the correct way and stuff like that. And also the types of message that you receive, the general format of the message that you receive. So the rest is just a style of APIs, or where API is everything.
I think it's more like fruit is an API, it's a generic term, and apple is like REST API. So you can have REST API. You can have
That's a
SOAP
best example,
API,
yes.
Very
things
good.
like that.
There we go, yeah.
But I've just never heard of any other API than REST API.
Yeah, there's
No,
a SOAP
these days,
API.
yeah, these days REST APIs are common, are getting common, and any application can consume the REST API. Previously, if it is not a REST API, everybody can't consume.
Yeah,
That's
I
the,
think
yeah.
it's just kind of showing the age of when I started programming, API was actually just an interface, right? Just a class with a specific interface that you call. Instead, and today APIs are usually associated to web services. So you see APIs today of something that always live on web. It was not always like that. Like REST APIs today live mostly on the web, but before it was not like that.
Yeah.
But that's just me showing that.
Yeah, these days everybody is releasing REST APIs so that everybody can consume.
Universal standard.
Yeah, universal standard, yes.
It's new flavor.
Okay, so if you have, I think this has a, by the way, all these slides are from Microsoft, so I'm just reusing them like how Wagner has done so. So if you have a cats, images of cats and images of dogs, you just upload them as cats and dogs, and then what the custom vision, and build a custom vision model. And for testing, if you upload a dog image, it will identify as a dog with a confidence level, giving a confidence score. And also if you upload a cat image, you will get a cat. But if you upload a horse, it will be in between. So you can try all these things. It's really easy to use custom vision, and you can enjoy, have fun with that. Oh, okay. This is not that helpful. I think I need to change the font. These are some of the links. Okay. Custom vision. What does, I'll go back to computer vision. Anyone remembers what computer vision does? What are the things? I have listed 4 things there. Can anyone say? OCR, yes. Face detection, yeah. Content moderation, yeah. Image classification, yeah. One more. OCR is done. OCR, image classification. Emotion, yeah, emotion, caption, whatever. Okay. Custom vision does only 2 things: image classification and object detection. See how the object is detected like a rectangles. So custom vision at the moment does only 2: image classification and object detection. And it also gives the predictions and what are the probability of what you uploaded is an apple or a banana or whatever. So now how do we build a classifier? You go to the website, create a project, select a domain, add images, assign tags to those images, and train the classifier and evaluate. See, those are just the steps, and it just doesn't take long. And a classifier is a model you build using custom vision service and by training a few images. And each classifier is equal to one project. So in those you can upload different varieties of differently labeled images to train the different labels. And there is a domain as well. So what is a domain? When you create a project, you select a domain for that project. You have to select a domain. So the domain optimizes what classifier, what specific type. General domain, and also general means it is general, like the term general suggests. And also there are some some domains which are provided by Microsoft. You can categorize them as use the domain as food, landmark, retail. Retail is sometimes you have a, let's say, a shopping website. So you have clothing apparel which you want to classify them as shirts, tops, dresses, shoes. Those kind of things can be done under retail. And if there is an adult content and non-adult content, you can use that as well as the domain. And food for apples, bananas, or different cuisines, those kind of things. And also landmarks, you can use both natural and artificial. Going on to training images. To create a high precision classifier, you need several images, several training images. A minimum of 15 images per label is recommended for giving a nice result, a close result. And there is something called iteration. Every time you train or retrain your classifier, you create a new iteration, which I'll show you. So in each iteration, it will create something called precision and recall. Precision is something that is number of objects identified, and recall is the number of actual objects, like actual number of apples versus non-apples. And for prediction, whether the uploaded images are really apples or not. It's identification, and this is identifying the actual, this is actual ones, this is just the prediction. I hope you understand. Yes? Yeah. Okay, so how do you test the model? Once you train, you have to test the model. So to test the model, you have some separate test images which are not in the train images. Then you upload those, and then you get the, once you upload those, you get the results with the probability and confidence levels as to against the tags that you have already uploaded. And then important terms, see, when precision is when you classify an image, how likely is your classifier to correctly classify the image? That is the precision. And recall is out of all images that should be classified, how many did your classifier identify correctly? So the actual classification. True positives, false positives. And using the prediction API, so here, once you create the trained model, you can publish it, and once you publish, it creates a prediction API which has these. So it has a key and what the content type is. Usually it's a JSON file, and then the URL, the endpoint. So you can use these. This is the, and you can use these and use these in your application. See, REST concepts. Standard is REST, and then you can use the get and post methods to against an API endpoint. So that's your endpoint URL, and there will be a prediction key which is something like that. And this is for C#, right? Mm-hmm. Yeah, this code is for C#. And train in the cloud. So we can use the custom vision service. Custom vision service is customvision.ai is the custom vision service. You can upload your images, train them, and then deploy and run anywhere. Okay, let's not go through these. How do you improve a classifier? The answer is here. So if you tag some images, if the testing is not returning what you wanted, as you have all answered, retrain the model and then publish it again. And also take it from different angles, take the photographs from different angles so that, and different object sizes, so that you can improve the classifier. And best practices for using custom vision is use at least 30 images. Images should be the focus of the picture. Yeah, not fuzzy like we have seen. And use sufficiently diverse images and backgrounds. Train with images with quality, and mostly they suggest white background. And supports Microsoft accounts and AAD. Okay, let's see some scenarios. So, okay, additional scenario says classify user submitted images to website, identifying elements, object counting. So, number, if you want to count the number of objects, like how I have said, you can use the custom vision hazard detection, for example. Yeah, adding rules to videos and yeah. I think we'll go to the demo. 15 minutes more. So you just go customvision.ai. Oh, am I over time? Think so.
On time.
On time? Okay. Just give me 2 minutes, I'll finish. So it talked about new project, right? So just go to custom vision.ai, just new project, and I am just giving AI Bootcamp CV, something like that, and you can enter a description and see here the domain, the project type is classification. It can do only two, classification and object detection. So these are the two, and you can choose if you want to multi-tag an image, you can do multi-label, otherwise multi-class, so single tag per image. And then you can use general, food, landmarks, retail, and so these ones, general, compact, food, compact, these are for mobile and also to export. So I'm just going to create the project, and then you can add images. So I'm just going to add a few images. See, I have images like this, training images. There are drills, hammers, hard hats, pilers, and screw drivers. I'll just add a few of screwdrivers. Let's say that, and then tag them as drills. Drill, I'll just say drill, and then upload these images. Come on, come on, come on, come on. Sorry? Sorry, I didn't get you. Yeah. Oh, yeah, GIFs also, yeah, you can add. Okay, so add, I will add hammers, a few hammers. I just want to show you how to test hammer. And I uploaded 15. Oh, luckily 15 under each. Just happened. Okay, so once you do that, see there is a train button here. So just train it. I am using quick train. And see, this is the iteration 1. And if we go to predictions, no, we have to first do a test. Oh, why isn't, okay, performance. Oh, it's still training, yeah, okay. Yeah, once it is trained, then you get this highlighted, and then you can upload the test image. I think I'm over. Sorry, guys. Yeah, it's that easy, so you can go and try. Come on, internet. Blame it on the internet. I think I have already. Okay, so I have already trained some images by uploading those two, drill and hammer. So I can show you a quick test. So go and upload a quick test. So I am uploading from not the training images but the test images. There are only 2. I want to upload this one. Let's see what it comes up with. So predictions, see here the predictions are there. Tag and probability. Hammer is, can everyone see? 99.5%. There is no hammer. Drill is 0.4%. That's not a good one. But if I upload drill, let's see the predictions. 100% hammer, 0%, sorry, 100% drill and 0% hammer. So you can keep on uploading different angles of photos, and that just gives you a capability of what custom vision API can do. So what's your answer for my question? Computer vision versus custom vision. Yeah, you can use your own images for custom, and also, but only you can do image classification and object detection. But the others, some others are possible for computer vision. Okay, that's it from me.